Hi guys, greetings from Bulgaria. I'm Anton, the coffee is here, so we are ready for yet another video for the awesome Lambda Test video channel. And in today's video we are going to talk about unit testing in Java. Let's take a look what we are going to talk about. So first we are going of course to talk about what is unit testing. There are really two famous unit testing frameworks in Java, JUnit and TestNG. We're going to cover both, but first we're going to start with JUnit since it's a little slightly more used than TestNG. I'm going to show you a standard setup for both in IntelliJ. We're going to talk about what are the annotations, the assertions, of course a little bit of how to run them in parallel, how to do a data-driven testing with different input parameters, and of course at the end we are going to do like a Selenium web tests together with JUnit, and we are going to multiply it based on different input parameters like product names. We are going to use the popular Lambda Test Playground website, and in the end we will see the same examples using TestNG. If you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified when new videos are published. Each week, new videos are out there. They will really help you to leverage your test automation game. And if you haven't checked the blog, check the Lambda Test blog. Many awesome articles, really helpful, many of fun. I check them to see what are the new trends, etc., and all of the best practices. So let's get started and let's discuss what is JUnit and TestNG and what are the unit testing frameworks. Usually in Java we use the unit testing frameworks besides the end-to-end testing and the UI testing. We use them to write tests about our production code. However, in test automation we use these open source frameworks, JUnit and TestNG, together with other libraries such as Selenium or Playwright. But with Selenium, they're separate libraries. But as you know, Selenium WebDriver, it's not a testing library, but instead it's a library that automates browsers. So we need this unit testing framework that give us like the engine for executing the tests, these annotations that we mark, basically all of the Java methods that these are tests. We can combine them into test suites. Also, we have this library for making the actual checks on the web page, the assertions. And of course, we have the command line runners. Many often during the night, using the command line runners, we execute the tests. So the unit testing framework is a combination about these libraries, tools together with their integration into the IDE. So the JUnit is really maybe the most popular unit testing framework for Java. It helps you to group your tests into test suites. You can prioritize the different tests. It has these comprehensive libraries for assertions and annotations, and the CLI execution and the integration with IntelliJ. So let's see a simple example here. In a minute, I'm going to show you how we can integrate it and write the same thing, but in IntelliJ. But here we have this class, my first JUnit Jupyter test. We are going to use JUnit 5, which is the latest version. And imagine that we are automating this calculator class, that it gives you basically a few methods for making calculations. In this case, we are adding these two numbers, 1 and 1 or 1 and 2. In this assertion library, basically we are checking that 2 is equal to the result of this particular method. And the thing that you need to notice here is this add test. This is called annotation. This is like a metadata that we are basically saying this method here, treat this method as a test. If we don't put this, you won't be able to execute it via the test engine. So let's see now how to set up a JUnit project. And by the way, we'll just touch just a few aspects of JUnit and TestNG. And there are a whole series about JUnit that I recorded myself in the Lambda Test channel. Please check them if you want to know more. Also, there are many awesome videos in the channel as well for TestNG if you want to dig deeper. So here is the project. It's a standard Java setup. We use Maven. We use Maven for downloading the dependencies. Here we specify that we are going to use version 19 of the compiler. And as I said, we're going to use JUnit 5. JUnit 5 is called Jupyter. So we need to install these dependencies for JUnit 5 in order to use the latest versions. So we need 3 dependencies: the API, the engine, and params. And I usually use the latest stable release version. And in order to use TestNG, of course, usually, in most cases, you're going to use JUnit or TestNG. You're not going to use both of them. But since this project, I'm going to demonstrate both. This is why I installed the dependencies for both of them. So for TestNG, you just need TestNG dependency. And since this will be like a project that we are going to write web tests, I installed Selenium Java client, the latest version. As you know, probably if you have followed the latest releases, this is the latest version at the current moment, 4.11, which is a really major version, because before, if you have experience with writing WebDriver tests, we require this WebDriver manager to download the particular drivers for different browsers like Chrome, Firefox, Safari. But with this version here, it uses internally the new Selenium manager, which is downloading behind the scenes the required drivers, and we are no more obligated to use this third-party dependency from Born Garcia. However, for backward compatibility, since it's still in beta, I will still continue to use the WebDriver manager. So, and also at the end, since I'm going to show you how to execute the test via the command line, you need this Maven Surefire plugin that is responsible for helping you to execute the test from the command line. Many often when we execute them in Jenkins, in Azure DevOps, in other continuous integration systems. If you are not familiar, there are awesome videos in the channel about this as well. So, I created under the test folder 2 packages, and the simple one is just to show you again this calculator application. Again, the calculator is just a simple class that has this add method that is basically returning the sum of 2 numbers, and then we have the same divide method for dividing 2 numbers. Nothing really special, I just wanted to show you an example without Selenium WebDriver. So we'll reach to this. This method order is basically in what order the test engine will execute your tests. Here I said please execute them every time on random. The first annotation that we discussed was this test annotation. As we discussed, you need to mark your methods or your tests with this annotation to be able to execute them as tests. If you do that, here from the context right mouse menu, you have this run and debug, and you will be able to execute this particular test. When we click run, as you can see, the project is building, and at the top left corner, you will see that we already executed our test, part of this calculator test suite. And now, however, you will see that we cannot execute this test here because we haven't marked it as a test. So we need to do that. As you can see, it's not displayed here. So we need to mark it again here. Another very often used annotation is before O. Since this class combines many of our tests, it's safe to say that this is like one small test suite combining a few tests about the calculator. So before all, gives you the possibility to reuse logic that needs to be executed just once for the whole test suite. Please note that this method is static, and this means that basically before all, as you can guess from the name, this will be executed only once for all of the tests. However, we have another notation called before each, and the before each will be executed before this test. Then when the execution starts for this test, first again will be executed the before each, and then the second test. We have similar annotations for logic to be executed after each test and after the whole test suite, after all and after each. So let's see an example with Selenium now, all right? The scenario that I'm going to automate is, as I said, we're going to use the Lambda test playground. We automated more than once in our videos. So here I'm going to search for a product, for example, iPod. Then I'm going to click search. And here the thing that I want to do is to find the same product that I search for example, iPod Touch or iPod Shuffle. I want to hover. As you can see on hover, this menu appears here, and I want to click Quick View. And with the Quick View, I want to verify the title, that the right product was loaded here, and I want to check the price. This is the scenario that we're going to automate. Now, I created another package, and I created a class called Product Details Tests, or Product Quick View, as you wish. We have the driver here as a private variable, and probably if you have some experience with Selenium, if you're not, please check the really detailed Selenium series on the Lambda Test channel, but I'm sure most of you are familiar. So here we use WebDriver, which is responsible for automating the browser. And there are two special classes, WebDriver Wait and Actions. You'll see them in a minute why we need them. But here I use, again, I define this before all in our test suite to download the proper driver. In order to be able to automate the browser, we need a specific driver, the Chrome driver, for example. In this case, we are using this third-party dependency that I mentioned, this here, WebDriver Manager, and it will download the proper drivers. It will, basically for Windows, it will detect the registry, it will see what is the version of my browser, and it will download the proper version. So we need to do this only once for the run, so this is why I executed it here in the before all section. And in the before each section, since I'm going, our first iteration, we are going to execute the tests on my local machine in my local browser. This is why I use driver equal to new Chrome driver. This will create a new instance of my browser, the Chrome. If I want Firefox, I'll use Firefox driver. And then I initialize the actions. Later, we will use this action class to do the hovering effect, the hovering on top of the element, right? And yeah, and the WebDriver wait, it helps us to do explicit waits, like, for example, we're going to wait for this pop-up to appear and to be fully loaded. In the end of each test, we're going to close the browser using the quit method. So let's see what we need to do. First, let's head to the home page. First, we need to find this input here. It's easy. As you can see, this is input element, and we can use XPath to find it by name. So I can say input brackets, then add name. As you can see, we use the add to find the name attribute, and then I want the search. This is the search. As you can see, it was highlighted above here. So this is how I'm going to find this, and then I'm going to type the text that I want, and then we need to click this button here. It's easy. We can find a button that it has this text here. So let's use again XPath button, and then text method equal search, and this is my button, and I'm going to click it. So iPod click search. Let's do it until here, and then I'm going to show you how we're going to click it. So since for the products, it's easy just to provide the title, right? But it's not just the title. We have the product code, we have the brand, we have the price. Also, if you add this product to be compared, if at some point we want to verify all of this text here, this means that we have a lot of data about each product. This is why here under main Java, I created a folder named models. And the model is basically a simple project class, plain class that it has just variables and getters. And we use this as a placeholder for holding the name, the ID, the price, the model, the brand, and the weight for each product. It's easy with IntelliJ when you create just the private fields. If you press Alt Insert, IntelliJ can generate, if you click here, getters and setters. For example, if I delete all those and I press Alt Insert, getters and setters, I can select for which field I want getters and setters, and IntelliJ is automatically creating all of them for us. However, as you can see, it's a lot of repetitive code. This is why you can use actually the pre-installed IntelliJ extension that gives a lot of new functionality to Java. And one of them is this data annotation. And the thing that this data annotation is doing is that actually it will generate compile time for you all of the getters and setters. And this is much more readable like this. You just place here data, and the constructor, the getters, the setters, and everything will be generated for you. So the first thing that I'm going to do in our method here is I'm going to create and initialize this expected product. It will be iPod Touch. I know the ID, the price, and everything. Then we're going to navigate to the home page that I showed you. We're going to find the search input using the XPath we generated. I'm using driver, find element, by XPath, input search, right? Then in order to type the name, we're going to use the getter like this, send keys, and we're going to type this name here. And after that, we need to click the search button that I'm going again with the XPath that I showed you before, button text search. And okay, we are on the previous page here of the search. The next thing that we need to do is we need to make this type of hover, right? And how we can do that? If I inspect again, it's a little bit crazy, but we have this link, right? It's marked here, over here. As you can see, this is the second product. And if you take a closer look to the ID here, you will notice that we have actually this, or maybe it will be easier for you here. If you take a closer look to the href, you will see that we have a product ID equal to 32. And we have the same 32 as part of the ID of the anchor. This means that we can create, for example, XPath. We can say contains, this is a method, ID equal to 32, which is the ID. And this is how we can generate this XPath by the ID that we have. After that, when you have here the quick view, we need to click afterwards this icon here, which is this button, which again, if you take a closer look to the class, basically we can select a button that contains this class and ends with this quick view / the ID of the product, which is 32. So I can say like this, button, brackets, not class, but we need to say contains class, and then quick view 32. Again, we are going to generate all of these locators using, we're going to check them using string format. And when you click it, we'll have to wait for basically this pop-up to appear, and we can wait for basically this h1, and this h1 is inside this div. So we can select the div by ID. This is the ID, and I can say I want a div where ID is equal to this, and we want to wait for div h1, and we're going to wait for it, and then we're going just to select the text and the price, and we are going to verify them. That's our game. So let's see how we can do that. So in order to generate the first XPath for the link, the image div, we use string format. If you remember, it's a link, an anchor. We use contains ID. This is the attribute, and we use %d, which is an integer, because this is an integer. This is the ID, and this is how we are going to generate this XPath. So we're going to find this product link using this auto-generated, generated XPath, and then we are going to use the actions class here to move to the element to focus on it. This will basically simulate the hover effect in order the quick view button to appear. To generate the quick view XPath, we use a similar approach. This is the name of this is basically the variable that holds this XPath, and we say, please find me a button that contains a class that has quick view / the actual ID that we get from the Pojo object, the model class specified here. And of course, we need to find it and click on it after we generate the XPath. Easy. Find element, and we use this string formatted XPath. And the next part is how to find in the quick view. This is now the assertion phase, assert phase. For the title, we use WebDriver weight. Again, there is a whole video about weights in Selenium. Check it out. You're going to find all of the resources in the description below and the full source code. So we use here the expected conditions, and basically we wait until the title is visible. And here is the title. I showed you the div with the ID, product, quick view, and then we have a few divs, h1. This will wait for the title of this view there, and then we get just the h3, which holds the price. And then we are going to use the assertions library that comes from JUnit. And here we are going to verify the data and the price, which is excellent. There is a whole video about assertions in JUnit, but basically this method allows you to compare two values. If they're not equal, there will be a really nice formatted exception pointing that probably there is a problem. Usually we provide first what we expect and then the actual results. In TestNG, as you will see, they're switched. First is the actual, then is the expected, but basically it's the same thing. All right, if you want to learn more about JUnit, for sure, check the official documentation. There is here JUnit 5 assertions. There are many of the methods with all of the examples there about assert all and everything. Assert all, assert true. There are different methods for asserting collections, asserting files, asserting strings, many different assertion helper methods. And now let's see how we can extend the solution. Since here we provided just a single product, iPod Touch, but as you can imagine, we might want to execute this test, but for various products that are in the search. We don't want to like basically copy paste the whole test right every time. And this is where you can use the data-driven tests. The data-driven tests, the thing that they will do is that through a parameter, I can supply, for example, the different titles of the products, and this test will be executed for each of the products that I specified. And this is exactly the thing that I did here. As you will see, since this is a second test suite, you will notice slightly different that here I'm extending a class, and I did that in order to reuse some of the logic. Let me elaborate really quickly on that. It's possible to have inheritance in unit testing. In this case, I'm reusing the before each and the after each. You will see here that I have this special class driver factory. It's basically responsible for reusing this initialization logic. It's nothing more than just a wrapper. For example, here I generated all of the capabilities to run these tests in the cloud in Lambda test. Let me quickly show you. Here in the Lambda test, it's excellent because we don't need to maintain our combinations between browsers and operating systems. Here you can pick from the generator all of these browsers with all of these versions. It has really nice capabilities for recording video for each test execution, taking script captures on each action. Later they're preserved here, and you can watch all the results, all the logs, all the networking, etc, etc. You can test on different resolutions, which is excellent for responsive testing, and many other advanced stuff that you can check as videos on the Lambda test channel. But again, we use this capabilities generator of the Lambda test to generate all of these capabilities, and basically this will be generated for you depending on your needs. And here we just generate this URL, and instead of Chrome driver or Firefox driver, I'm using the remote WebDriver, which will connect to the cloud. And of course, you need to initialize this environmental variables for your username and access key for your account. And you will wonder now, what is this thread local? We need this thread local because the power of the cloud is that it gives you the infrastructure to execute your tests in parallel threads. But in order to do that, we can use JUnit or TestNG. In order to execute the tests in JUnit in parallel, we need this properties file called JUnit platform properties. And if we enable these three lines here, we enable the parallel execution, we are saying please execute them concurrently. I suggest like you can run the tests, each test in another thread, in another process. Usually my approach is to execute the different test suites in separate processes, which will allow you to, sometimes there are problems with the test data, etc. between the different test suites. So most probably if you're running Selenium tests, you end up running different test classes in parallel. So when you enable that, if you don't have these thread local things, probably your tests are going to mess up, because one of the process will control the browser of another process and they will get messed up. This thread local basically says, give me the correct version of the driver for this particular process. Basically, it's like a container. Again, there is a whole video about executing the test in parallel with JUnit. Check it out. But this is why I use it here. So in our web tests base class, the thing that I did is that basically before each test, basically I'm saying connect me to the cloud, execute the test there, and after that close the browser. That's everything that I'm doing. And after that, this is the same test copied here. It will just execute it there. However, as I said, we want to, for each product to execute the tests, not to repeat the whole body, but as here, we have this special annotation called value source in JUnit. This means that this test will be repeated for each of these lines, for each of these products. And this value here, it will be populated here. We will execute the test, then our next text will be executed, but for this variable here, the test engine will pass this value here. And also it will, using this parameterized test annotation, we instruct JUnit to execute this test in a data-driven manner. And we will reuse the whole body of the tests. Right here, I used a special class called product details factory. I'm doing nothing more than this is just a simple static method. We are populating 3 of the products inside this list, and I'm returning it. And then using Stream API, I'm just returning the first product, which name is equal to the product name that I pass here. Maybe we can refactor it later directly to initialize a map or the so-called dictionary where the name will be the key and then the value will be the actual product detail, but will be up to you. Another way how we can achieve the same without the factory is to use this CSV source annotation, where as you can see we have more information. We have all the information for the product details, but I separated them with commas here, right? And as you can see here, we have many more parameters, like we have 5, 6, we can have even more. And every time I'm initializing my product details, basically the thing that JUnit will do, in the first execution of the test, it will get this line and it will split it by comma, and for each splitted value, it will initialize the different parameters here, and we're going to initialize the expected product, and then we will continue. There are also other more advanced things, like for example, we have this argument source where we can have these providers that basically we are initializing the same product, but in a slightly different manner using streams and arguments. This is slightly more complex. You can check it out, but again, there is a whole video about data-driven tests. Check it. So yeah, data-driven tests really helpful. And also, what are these tags? Lastly, we use them when we want to execute the tests through the command line. And what is the command? We usually use this Maven Surefire plugin that I showed you before. If I click here, open terminal, and below, if I use this command, Maven test and dgroup nightly run is this tag. Selectively, I can run just the test with a particular tag. Many often we provide tags for continuous integration, nightly run, for particular feature. We separate them in JUnit into different test suites using these tags. And really quick, for TestNG, basically the tests are quite similar, but the notations are different. Basically, instead of before all, here the notation it's called before class. And watch out because the method it's not static now. And instead of before each, we have this before method. Besides that, is the same. We have before method, after method, instead of before each, after each. Then we have the test. Also, the data-driven tests are a little bit different Here we don't have this special annotation for this data-driven test, but we just use the standard test, but you need to provide this data provider. And then with the data provider, we specify the class that it's generating this special array, double array with the values. It's a little bit weird. This is why I said that I prefer JUnit. We can have a data provider for the CSV files, etc. And another difference is that with TestNG, we can have this XML test suites where we specify the different classes or test suites within this bigger test suite. And also we can define the different tags here with this inclusion. The command for executing the test via the CLI, it's a little bit different. It's Maven test, and then we provide this XML file. But it's excellent because if you check the official TestNG documentation, we have many commands for the TestNG. I think we covered most of the things that I wanted to show you. Thank you for watching. I hope that it was useful to you. Again, check the videos because there are many detailed videos about each of these topics. This was a little bit more general overview about the unit testing in Java. Check the blog. And if you have any comments or questions, put them in the comments section below. You will find in the description many of the resources and the whole source code. And be sure to check the Lambda test website for the different certifications about JUnit, TestNG, and Selenium. Thank you for watching and see you in the next videos. Bye.